I'm Alex. This is Code Along with Alex, and today we're going to run a single instance stateful application with Kubernetes. Let's get into it. Let's go right to the docs. So this page is going to show us how to run a single instance stateful application in Kubernetes using a persistent volume and a deployment. And so the application in question is MySQL. So some high-level objectives for today. We're going to create a persistent volume referencing a disk in our environment. We're going to create a MySQL deployment and then expose MySQL to other pods in the cluster at a known DNS name. So before you begin, you're going to need a Kubernetes cluster and kubectl configured to communicate with that cluster. I'm using Killer Coda, Kubernetes Playground. Use whatever tool you like, but for the sake of learning and teaching and running these sessions, Killer Coda is great. So I recommend that, but for production environments, it's definitely not appropriate. But for learning, it's awesome. So let's check that we have kubectl configured. So you can see we're good to go. So to start, let's deploy MySQL. I guess we're going to need to have a dynamic persistent volume provisioner with a default storage class, or statically provision persistent volumes ourselves to satisfy the persistent volume claims. We'll come to that when we come to that. But to start, let's just deploy MySQL. Clearing out the terminal output just to make things a little neater. So let me do a little bit of blurb reading, and then we'll get back to code, or to YAML appreciating, to be honest. You can run a stateful application by creating a Kubernetes deployment and connecting it to an existing persistent volume using a persistent volume claim. For example, the YAML file that we'll see in a second describes a deployment that runs MySQL and references the persistent volume claim. The file defines a volume mount for varlib MySQL and then creates a persistent volume claim that looks for a 20 gigabyte volume. This claim is satisfied by any existing volume that meets the requirements or by a dynamic provisioner. And then a note that the password is defined in the config YAML, and this is insecure. And so using something like Kubernetes secrets is a much more secure option. So I guess to start, before we even dive into the YAML, reading through this deployment blurb and that the persistent volume claim is going to look for a 20 gigabyte volume, I don't think that this is going to work on Killer Coda just because this system is generally pretty small. So we'll see, but I might have to submit an issue that they need to remove Killer Coda from the recommended playgrounds on this specific lesson. But I could be speaking erroneously now, so I'll pause until we verify. So let's return to the documentation. And so this is the YAML for our MySQL deployment that we'll download shortly. But to start, we're just going to kind of inspect it. It looks pretty similar to previous YAMLs we've glanced at, and really just nothing too different. As described above, the password is not particularly secure, so using Kubernetes secrets is a much better option. And then so this was the deployment for MySQL. Now we're going to look at the deployment for the persistent volume claim. So a little different, but it's kind of connecting to aspects of the previous YAML we just looked at. As discussed above, it's looking for a 20 gigabyte volume. So let's just go for it and see if this works. I'm not too optimistic, but if it works, I'll be very pleasantly surprised. And yeah, who knows? Miracles happen. It's the holiday season. Almost. Okay, so we're going to run kubectl apply, pass the F flag, and then download the persistent volume or deploy the persistent volume and persistent volume claim from the YAML file specified here. So let's press enter and see if things happen. I don't know that this is going to work. And I know I've said that a few times just because I've tried similar lessons in this playground that require more space, and it wasn't stoked. And by it, I mean the playground. It just never finished the commands. And so I'm definitely a little jaded. Or not jaded. I'm having flashbacks. Okay, so now let's deploy the contents of the MySQL deployment. So I was a little lazy and I copy pasted there, but it's the same kubectl apply -f and then passing a different URL. Awesome. So let's display information about our deployment. So to do that, I'm going to do kubectl describe deployment MySQL. So you can see name, MySQL, namespace, creation time, no labels, no annotations, just the selector, and then information about replicas, information about the MySQL image. And then we look a little further, some stuff about persistent volume claim. And then it looks pretty good. Okay. I'm surprised. Sorry for being so pessimistic to start. Okay, so let's get our pods. We're going to do that by running kubectl get pods -l, and then we're going to filter specifically to the MySQL app, just so we're not getting all the pods, in case there are many pods in our cluster. So you can see we have a single pod running with 0 restarts, and it's like a minute and a half old. I mean, that lines up with kind of what we did in the time frame that we did it. So next, let's clear this, and let's inspect our persistent volume claim. So to do that, I'm going to call kubectl describe, which is something we've been using pretty frequently, but instead of deployment, which is what we were running before, I'm going to do PVC, which is short for persistent volume claim, and then we want to pass MySQL PV claim, because this is the name of the persistent volume claim we defined in the YAML previously. Awesome. So let's check out our output. So we've got information regarding the storage class status, the volume name, labels, any annotations, the capacity, and then a warning, a provisioning failed for the persistent volume controller storage class. Manual not found. Interesting. So this could be an error that I had foreshadowed previously, but we'll see. So let's access the MySQL instance. So to do that, we'll do kubectl run -it -rm, Oh, there's a, excuse me, dash dash rm dash dash image equals MySQL colon 5.6 dash dash restart equals never MySQL dash client, and then dash dash MySQL dash h MySQL dash password. This looks weird. Like that's, I don't know if that's an intentional double P. It is in the docs. So this might be a typo, but we'll see. So this command should create a new pod in a cluster running a MySQL client and connect it to the server through the service. If it connects, we'll know that our stateful MySQL database is up and running. And if it doesn't, we'll know something's wrong. Yeah, it doesn't seem to be digging it. So let's cancel. Let's press enter. See if that does anything. Oh, there we go. Interesting. So that did work, I guess. I'm Googling some MySQL commands really quickly to see what we can do. I don't remember any off the top of my head. How do we list the databases? Show databases. Am I missing something? Oh, semicolon. Okay, interesting. So we're actually connected to the MySQL database. Very cool. I guess I was skeptical for no reason. My bad. I was being a negative Nancy. Let's see what tables are in the DB. Show tables, or let's use MySQL, and then let's show tables. Okay, cool. Yeah, no, like we're straight up in MySQL in Kubernetes. Nice. Okay, rad. Pleasantly surprised. So let's exit our MySQL. Yeah. So now we're back at the control plane. And so let's clear this just to make it a little neater. And now that we've kind of done our whirlwind tour of MySQL on Kubernetes, we need to clean up. And so let's deploy, or let's delete our deployed objects. And we're going to do that by name. So kubectl delete deployments svc MySQL. Interesting. Okay. Oops. And then we'll delete the persistent volume claim. And then finally, we're going to delete the persistent volume. Beautiful. Awesome. That was it for today. Thanks for hanging out. Really appreciate your company. This was another short one. Yeah, I'm Alex. This has been Code Along with Alex. I'll see you next time.